Welcome to the safety training on laser cutting and engraving. The training is aimed to help HKBU users to understand 1. Basic laser principle. 2. Laser safety. 3. Safety of laser cutting and engraving, with a focus on safe operation of laser cutter engraver provided in prototyping room of CollabTech Commons. After completing the test in Moodle, you are eligible to make a booking of the equipment. You may request in-person training during your session if this is your first time using the equipment. Supervision on your operation by authorized staff is always a must. The library reserves the right to require you to undergo hands-on training, even if you claim to be an experienced user. The library also reserves the right to refuse or terminate any session by pausing your work or cancelling your reserved session, and to require you to leave the room and the library immediately. Please note that this training is not provided for Class 3R, 3B, 4 laser equipment. It is our agenda. Our training is separated into 2 parts. In Part 1, we would go through general knowledge related to laser cutting and engraving. Introduction to laser. We would go through the basic knowledge on laser. Then, in laser classification, we would introduce the classification of laser and the EMSD guidelines on safety. Then, we would introduce laser cutting and engraving. Then, we would talk about typical health hazards associated with laser cutting and engraving. Then, in Part 2, which is another training session, we would go deeper into the machine that works on laser cutting and engraving. We would talk about the essentials features of laser cutter, engraver, then how to operate it safely, and finally, the emergency procedure. What is laser? Laser stands for light amplification by the stimulated emission of radiation, which has already summarized the laser generation mechanism. We will briefly introduce it in later slides. Lasers are more powerful than the ordinary light we use and see in daily life, so we must pay more attention when we use laser equipment. Here are some key physical properties that make laser light different. Firstly, laser light is composed of single color, which means mainly a single wavelength of light wave. It is different to ordinary light, which is composed of different colors, which can be seen using a glass prism through refraction. Secondary laser light are directional, which mean the light waves typically move together in the same direction, while ordinary light is typically multidirectional. Thirdly, laser light moves synchronously in same phase. Ordinary light typically moves in a more random manner. These physical properties make laser light interfere constructively to enhance their power along the beam path. Laser generation typically requires 3 components. First is energy source to supply energy. Second is gain medium to absorb the energy and generate light waves of target wavelength. Third is reflector, which works with the gain medium to continuously generate coherent laser light in same direction and let part of the laser out to form laser beam. Conventional laser generation equipment is much larger in size. The energy source can be light or electrical source. The gain medium can be gas, solid or liquid. One side of the gain medium is a total reflector to reflect all light waves, while at the other side is a partial reflector, which keeps reflecting part of the light wave back to gain medium to amplify the power, while let part of the light wave move out to form laser beam. Semiconductor laser is another kind of laser that uses p-n junction to form the laser. It adopts quite a different design and is much smaller in size. We can find it in daily equipment like CD, DVD, and Blu-ray reader. For simplicity, let's stick to the conventional design first when you try to imagine and understand the laser generation mechanism. Here is the physics of laser generation mechanism. Step 1. Energy input into gain medium. The energy source provides energy to gain medium to be absorbed by the atom inside. Atom in different gain medium would have different energy levels and thus different size of gap between energy levels. This gap determines what wavelength of energy the atom can absorb, store, and emit. Step 2. Spontaneous emission. Atom that has absorbed energy become excited. Excited atom becomes unstable and tend to emit the energy out naturally. The emitted energy has the wavelength that matches with the gap of energy levels of the atoms. This emitted energy can also be called photon. Step 3. Stimulated emission. The emitted will move through the gain medium. When it passes through other excited atoms, it stimulates the excited atoms to emit photons of same wavelength that move in same direction and coherently. It thus amplifies the amount of light. Step 4. Laser output. Part of the amplified light leave at the partial reflector to form laser beam, while other part is reflected to continue the amplification process. It is how laser source generates laser continuously. It is a table about how different materials of gain medium would emit different wavelengths of energy and their application. For example, CO2 gain medium would help to emit laser light at wavelength 10,604 nanometers, which is in the range of infrared red. Suitable wavelengths of lasers must be chosen for different applications. For example, the laser light emitted from CO2 laser does not have wavelength efficiently absorbed by metal, and thus CO2 laser is not suitable for cutting metal. Lasers are widely applied in different fields. For example, in medical fields, it is used for kidney stone removal, while in scientific research, it is used in LiDAR system to detect weather conditions. Lasers are often used in the laser show for entertainment. In daily life, we can also often see the use of laser, like barcode scanner when we check out in supermarket, and DVD reader at home. We also have laser cutting and engraving for industrial use, and laser used in optical fibers for communication. Now let's move on to the laser classification. The EMSD of Hong Kong government has a web page providing laser safety guidance, which are composed based on International Stand IEC 60825, provided by International Electrotechnical Commission. Our laser safety and classification would be based on the guidance provided by EMSD. Laser product can be classified into Class 1, 1M, 2, 2M, 3R, 3B, and 4. When laser equipment is used, always pay attention to the class of laser and understand the corresponding safe way to use. Different classes would require different labeling requirements on the laser machine, including information on explanatory labels and warning labels. Here are some examples of labels, which typically use yellow background and black wordings to catch your attention and tell the information of the laser and the safety action users must pay attention to. For example, the label located at the top right corner of the slide is telling that some laser equipment would become Class 4 laser product if the protection mechanism of the laser equipment is removed when the laser runs. It reminds you of the conditions that would make it a Class 4 laser and the potential danger you must know. Now let's go deeper on each class of laser. Class 1 laser product is regarded as safe under reasonably foreseeable conditions of operation, including the use of optical instruments for intra-beam viewing. Examples are laser printers and compact disc players. Class 1M laser product is also regarded as safe under reasonably foreseeable conditions of operation, but may be hazardous if the user employs optics within the beam. Examples are fiber optic communication systems. Class 2 and 2M laser products have higher risk than Class 1 and 1M. For Class 2 laser products, it is considered not inherently safe for eyes, but protection on your eyes by natural aversion response is usually adequate. Examples are laser pointers and barcode scanner we use in supermarket. For Class 2M laser products, eye protection by aversion response is also advised. The product would also become more hazardous if user employs optic within the beam. Example is the level and orientation instruments for civil engineering applications. Class 3R, 3B, and 4 laser products are considered potentially much more hazardous to eyes in direct intrabeam viewing. Natural aversion is not enough for eye protection from these laser products. Class 4 laser products are the most potentially hazardous one. It is a high-power output device. It could cause not only damage to eyes, but also skin injuries. It could also constitute a high chance of fire hazard. The reflections of the laser can also be very hazardous. Extreme caution are required when it is used. These are the safety guidance when different classes of laser products are used. As a user, 1. Never view directly at a laser beam. 2. Never aim laser beam at anyone's eyes. 3. Understand the information of explanatory and warning label, which manufacturer affix on the laser products. For Class 3R, 3B, and Class 4 laser product, the EMSD provides much stricter guidelines, including appointment of a designated laser safety officer to handle all the control measures, and wearing protective goggles and clothing. Now let's move on to introduce laser cutting and engraving. The laser itself used by laser cutter, engraver, typically fall in Class 4 category. However, the whole laser cutter, engraver machines are usually categorized as Class 2 or even Class 1 because it is designed to have protection mechanism when the product is used in expected way. For example, machine is enclosed with interlock when the laser is on. Interlock is usually installed at the doors that can be easily opened to turn laser off immediately if the door is opened. Laser cutting and engraving are material processing techniques that use a focused laser beam to remove material. Cutting is about completely cutting through the material using laser at high power and slow movement. Engraving is about mainly removing the part of the material on surface. The laser system uses a series of mirrors to transfer the laser beam from laser source and use lens to focus and bring the laser to the material. Motion is controlled by your setting input into computer. The mechanism behind material removal is that, firstly, material absorbs energy from laser. Secondly, amount of absorbed energy meets threshold of ablation. Ablation can be evaporation, sublimation, or chemical decomposition. Finally, material is evaporated and removed. As mentioned previously, different materials would absorb different wavelengths of energy. Suitable lasers must be selected to optimize the processing efficiency. Laser output typically has 2 modes. One is continuous mode. Laser output continuously and consistently. It can process material fast and good for high-volume production. The other one is pulsed mode. Laser output at high peak burst of short duration, while the average output can still be same as continuous mode. It could cause less thermal damage, like charring, and less surface distortion to material. It is good for producing fine features. Some laser machines allow to choose the frequency of pulses during laser cutting to make the processing quality suitable to the need. The laser machine is also a device using computer numerical control principles to control the motion and laser output. Users may use software like CorelDRAW, Adobe Illustrator, SolidWorks to prepare 2D drawings. Users will need to assign laser power and speed to different colors of line or area in the drawing. Then load all the processing instructions into the computer, including power, speed, and 2D drawing. The controller then follows the instructions to control the laser output and XY motion to conduct cutting or engraving. These are examples prepared by laser cutting or engraving. Laser engravings are used to put drawing on pieces of acrylic and wood, then apply cutting to take it out. Laser cutting can also be used to cut out parts to be assembled to form a model. Since the laser beam has a radius, margin will have to be given in the drawing so that the parts can fit with each other tightly. Now, Let's talk about health hazard we should be aware for laser cutting and engraving. Here is overview of common hazards of which we must be careful. Eye damage. As discussed before, laser beam can cause serious damage to the retina and vision impairment which could be irreversible. Never disassemble protection mechanism of laser machine or look at the beam directly. Skin burns and cut. High-power laser beam can cause irreversible skin burn. Materials processed by laser cutter beam may have sharp or uneven edges of cut, which can cut skin. Besides, it is still very hot right after processing. Toxic fumes. Fume is emitted after laser processing, and some material would release highly toxic fume. Fire hazard. Laser cutter beam can ignite flammable materials and cause fires. High-power laser beam can cause very serious and irreversible damage to our eyes, even in a very short duration. Eyes are especially susceptible to the damage by laser beam, especially at wavelength between 400 to 1400 nanometers. The laser beam will be focused by lens to a spot-size area on retina, where the energy is concentrated and causing very serious damage. Even the reflection of powerful laser beam could also be very dangerous. About the hazard come from material interaction with laser. Acrylic and wood would emit irritating and harmful fume, but generally accepted by maker labs with suitable air ventilation and filtering. However, direct and long-time exposure is still harmful to human health. Some materials which may pose danger to human health and damage to the laser machine are generally prohibited. The first to pay attention is PVC. Do remember, no PVC is allowed. The fume it emitted are not only very toxic, but also damaging to the laser machine. Processing PVC is strictly prohibited, and it would immediately void the machine warranty. Below are some examples of material that are not suitable to laser cutting or engraving. Some materials like PTFE, epoxy, PC, ABS, HDPE, fiberglass, carbon fiber would also emit highly toxic fume. Some materials like PS foam and PP foam are highly flammable, and thus they are not suitable either. Some materials that are highly reflective to wavelength used by the laser machine are not suitable too, since the reflection may also cause damage. Dangerous materials are not limited to those just mentioned. And one very important thing to remember, never process unidentified material, and it will expose you to high and unknown risk. About fire hazards, the material being processed by laser beam can become very hot. Suitable ventilation for cooling and removing the combustible gas and dust generated during laser processing are always needed to minimize fire risk. Regular cleaning to remove accumulation of dust and debris from the chamber is also a good maintenance habit to remove combustible material. Furthermore, too dense or too close cutting lines in the drawing would cause huge accumulation of heat in a short time and thus should also be avoided. Part 1 is finished here. Please move on to Part 2 to continue the training.